I want to propose something that will seem impossible the moment you hear it. And then I want to spend the next 90 minutes showing you why it is not only possible, but precisely correct. Light does not move. I do not mean this as a koan or a provocation. I mean it as a statement of physics. In the four-dimensional space-time block, that special and general relativity established as the correct description of the universe, the photon, the quantum of the electromagnetic field, the fundamental particle that constitutes a beam of light, does not travel. It does not go anywhere. It does not leave one place and arrive at another. It simply exists all at once along the entirety of what we call its path, from its moment of emission to its moment of absorption. This is not a poetic restatement of the zero proper time result that I described in the previous video. It is a more radical claim that in the block universe picture, the concept of motion itself, the idea that an object is at one place at one time and a different place at a later time, does not apply to the photon in the way it applies to any other physical object. The claim sounds paradoxical because everything in our experience of light contradicts it. We see the sun and we know the light took 8 minutes to arrive. We look at a star and know the light took years. We photograph a distant galaxy and know the light spent billions of years in transit. In every case, light seems to travel, it leaves a source, traverses a distance, and arrives at a destination. The travel is real. The arrival is real. The 8 minutes are real. I am not denying any of this. I am saying that what I just described, the 8-minute journey, the traversal of 150 million kilometers is real, from the perspective of an observer moving along a time-like world line through the space-time block. It is real in coordinate time and coordinate space. It is measured by clocks and rulers. It is confirmed by experiment. What is also real, and what is stranger, is that in the Minkowski metric, the physically invariant metric of space-time, the photon that traversed 150 million kilometers in 8 minutes accumulated zero invariant distance. Zero. The invariant space-time interval from the emission event to the absorption event is exactly zero. Not approximately zero, exactly zero. And in the block universe, where the invariant metric is the physically meaningful measure, this means the photon occupied a geometric object of zero extent. An object that occupies a geometric object of zero invariant extent does not move in the physically meaningful sense. It does not traverse a distance. It does not take time. It exists along a null geodesic that, in the invariant metric, is a single point. This is the paradox I want to resolve. How can light both travel covering 150 million kilometers in 8 minutes and not move occupying a null geodesic of zero invariant extent at the same time? The resolution will take the full arc of this video to develop, and it touches everything from the philosophy of motion to quantum field theory to gravitational lensing. But the resolution is complete and consistent, and it is the picture that the physics actually provides. Let me build this argument from 3 directions simultaneously, because the full picture requires physics, geometry, and philosophy working together. The first direction is the block universe itself and what it implies about the nature of motion for any physical object, not just the photon. The second is the null geodesic and what it means geometrically for an object to have a world line of zero space-time length. The third is the question of what motion actually means in physics, what conditions are required for the concept of motion to apply, and why the photon fails to satisfy those conditions. Let me begin with the block universe, because it is the foundation on which everything else rests, and because the block universe changes what motion means for every physical object, not just for the photon. The block universe is the picture of space-time that emerges inevitably from the relativity of simultaneity. I derive this in the block universe video because different observers in relative motion disagree about which events are simultaneous. There is no universal present moment. The division of events into past, present, and future is observer dependent. The only consistent ontological position is that all events at all space-time coordinates are equally real. The four-dimensional space-time manifold contains all events at their space-time coordinates, and the complete space-time block is physical reality. In the block universe, nothing becomes, nothing passes. Every event simply is at its space-time location. The Big Bang is there in the block at its space-time coordinates. Your birth is there. This moment is there. Your death is there. Every moment of history, every moment of the universe's future is equally real, equally present in the four-dimensional structure of the block. In this picture, the world line of a massive particle, an electron, an atom, a planet, a person, is a curve in the four-dimensional block. The curve connects the event of the particle's creation to the event of its annihilation. Along this curve, the particle exists at each space-time point it passes through. Here is the critical point that is usually overlooked in discussions of the block universe. The particle does not move along its world line. The world line is not a trajectory traced out over time, like a pen drawing a line on paper. It is a complete, static, four-dimensional object that represents the particle's entire space-time history. The particle exists at every point on its world line simultaneously, in the sense that all events in the block are equally real. When we say the particle moves from position A at time t1 to position B at time t2, we are describing two different points on the particle's world line and saying that the world line passes through both. The particle at A is one event. The particle at B is a different event. Both events are in the block. Both are equally real. The particle does not move from A to B. It exists at A and it exists at B, and every point between them simultaneously in the block. What we experience as motion, the particle being here and then there, is a feature of our traversal of the block along our own world lines. We, as observers, move through the block in the sense that our world lines advance through the space-time coordinates. As we do, we encounter the particle's world line at successive points on our own world line, and we experience this as the particle being at different positions at different times. But the particle is not moving. The particle is static in the block. We are moving through the block, and as we do, we intersect the particle's world line at successive points. This reconceptualization applies to all motion in the block universe. A thrown baseball is not moving from the pitcher to the catcher. The baseball's world line exists in the block, a parabolic curve connecting the throw event to the catch event. The baseball is at every point on this world line simultaneously in the block. What we experience as the baseball's motion is our traversal of the block intersecting the baseball's world line at successive points on our journey. Strictly speaking, no object moves in the block universe. Every object simply is at every point on its world line simultaneously in the block. What we call motion is the experience of observing world lines from the vantage point of our own world line traversal. This is true for massive objects. For the photon, something additional and more dramatic is true. The photon's world line has zero invariant extent. But to understand the photon's peculiarity, I first need to establish this general block universe understanding of motion for all objects. Ready to change how you see the world? The implications of the block universe for the concept of motion, that no object moves in the block, but all objects exist statically along their world lines, are one of the most transformative ideas in the 12 principles I've assembled for understanding the fabric of reality. Get your copy of 12 Principles for Understanding the Fabric of Reality at realityprinciples.com. Now apply this block universe picture to the photon with the additional feature that the photon's world line is a null geodesic of zero invariant length. In the block universe, the photon's world line is a curve connecting the emission event to the absorption event. Every point on this curve, every intermediate space-time location between emission and absorption is equally real in the block. The photon exists at the emission event, at the absorption event, and at every point between them. But the photon's world line is a null geodesic, a curve along which the Minkowski metric interval is 0 at every point. The interval ds squared equals c squared dt squared plus dx squared plus dy squared plus dz squared evaluates to 0 at each infinitesimal step along the photon's path, because the photon moves at exactly c and the temporal term and spatial terms cancel precisely. The integral of this zero-valued interval along the entire null geodesic is 0. The null geodesic has 0 Minkowski length. In Euclidean geometry, a curve of 0 length is a point, a curve that begins and ends at the same location and traverses no distance. In Minkowski geometry, the situation is different. A null geodesic can connect events that are far apart in coordinate space and coordinate time, while still having 0 Minkowski length. The 0 length is not because the events are close in coordinates. They can be billions of light years apart. The 0 length is a consequence of the specific way the temporal and spatial terms cancel in the Minkowski metric along a null curve. Nevertheless, the 0 Minkowski length has a precise geometric meaning. The emission event and the absorption event are in the Minkowski metric at 0 spacetime distance from each other. They are in the invariant geometry of spacetime, the same spacetime location connected by a geometric object of 0 extent. This is what makes the photon unique among all physical entities. For a massive particle, the world line has non-zero Minkowski, specifically c times the proper time along the world line. The proper time is positive for any finite segment of a massive particle's world line. The emission and absorption events of a massive particle are at non-zero Minkowski distance from each other. For the photon, the world line has 0 Minkowski length. The emission and absorption events are at 0 Minkowski distance. And in the block universe, where the Minkowski metric provides the physically invariant measure of space-time separation, the emission and absorption events are, in the invariant geometric sense, the same event. This is not a coordinate artifact. The Minkowski interval is invariant. It has the same value for all observers. Every observer, regardless of their velocity, agrees that the Minkowski interval along the photon's world line from emission to absorption is 0. The 0 Minkowski distance between emission and absorption is a physical fact independent of any observer or coordinate system. So the photon exists along a null geodesic of 0 invariant extent, connecting two events that are in the invariant geometry at 0 spacetime distance. In what sense has the photon moved? In the invariant sense, the sense that the physics uses it, has traversed nothing. It exists at a geometric object of 0 extent. It is at both the emission event and the absorption event. And these events are at 0 invariant distance from each other. This is the first sense in which light travels without moving. In the block universe, with the Minkowski metric as the invariant measure, the photon traverses 0 space-time distance between emission and absorption. It does not travel from the emission event to the absorption event. Both events are at 0 Minkowski distance from each other, and the photon exists at both simultaneously in the block. Let me now develop the second direction, the geometry of the null geodesic and what it implies about the nature of the photon's world line, with the mathematical precision that the argument requires. A geodesic is the straightest possible curve in a given geometry. In Euclidean space, geodesics are straight lines. In general relativity, geodesics are the world lines of freely falling particles' curves that extremize the proper time between two events. The key distinction in Minkowski spacetime is between three types of geodesics, classified by the sign of the metric interval along them. Time-like geodesics have negative metric interval at every point. ds squared is less than 0. These are the world lines of massive particles. Along a time-like geodesic, the proper time d tau equals sqrt ds squared divided by c squared is real and positive at every point and increases monotonically along the world line. Space-like geodesics have positive metric interval. ds squared is greater than 0. No physical particle can follow a space-like geodesic, as this would require faster than light travel. Null geodesics have 0 metric interval at every point. ds squared equals 0. These are the world lines of massless particles, photons. Along a null geodesic, the proper time is 0 everywhere. d tau equals sqr, 0 equals 0. There is no proper time parameter that increases along the null geodesic. The null geodesic has 0 Minkowski length. The length is the integral of ds equals 0 along the entire geodesic, which is 0 regardless of the coordinate extent of the geodesic. A null geodesic spanning 10 billion coordinate light years has 0 Minkowski length. The Minkowski length is invariant the same for all observers, and it is exactly 0 for all null geodesics. This 0 Minkowski length is the geometric statement that the photon traverses 0 invariant distance. In the physics of spacetime, where the Minkowski metric is the physically invariant, measure the photon's world line from emission to absorption occupies no extent. The emission and absorption events are at 0 Minkowski distance from each other. Now let me address what motion means in this context, because the concept of motion depends on both the geometry and the existence of a well-defined proper time parameter. Motion, in the most fundamental physical sense, means traversing a physical distance over a physical time. For a massive particle, both are defined by the worldline geometry. The proper distance is c times the proper time, and the proper time increases along the worldline. A massive particle's velocity, in the proper time sense, is the change in position per unit proper. For the photon, both proper distance and proper time are 0. There is no physical distance to traverse and no physical time in which to traverse it. The photon does not move in the proper time sense. It exists along a null geodesic of 0 proper extent. The coordinate velocity c is not the photon's proper time velocity, it is a geometric property. The slope of the null geodesic relative to the observer's time-like coordinate direction. For every unit of coordinate time, the observer advances, the null geodesic advances c units in the spatial coordinate direction. This is not a rate of traversal. The photon is not traversing c units per second of its proper time because it has no proper time. It is a geometric ratio between two directions in the space-time block. A geodesic is the straightest possible curve in a given geometry. In Euclidean space, geodesics are straight lines. In general relativity, geodesics are the world lines of freely falling particles curves that extremize the proper time between two events. A massive particle in free fall follows a time-like geodesic, a curve along which the space-time interval is negative, and the proper time is the square root of the absolute value of the interval integrated along the curve. A photon in free space follows a null geodesic, a curve along which the space-time interval is 0 at every point. The null geodesic is the limiting case of the time-like geodesic as the particle's rest mass goes to 0 and its velocity approaches c. In this limit, the proper time along the geodesic approaches 0, and in the limit, the proper time is exactly 0. The null geodesic has a property that no time-like geodesic shares. It has 0 proper length. The length of a curve in Riemannian geometry is the integral of the line element along the curve. For the Minkowski metric, the line element for a null curve is 0 at every point. So the integral of the line element is 0. The null geodesic has 0 length in the Minkowski metric. This 0 length is not a consequence of the geodesic being short. The null geodesic from a galaxy at 10 billion light years spans 10 billion coordinate light years and 10 billion coordinate years, but its Minkowski length is 0. The Minkowski metric is not the same as the coordinate metric. The coordinate metric, ordinary Euclidean distance in space, assigns 10 billion light years to the photon's path. The Minkowski metric assigns 0. Which metric is the physically meaningful one? In special relativity, the Minkowski metric is the invariant metric. It gives the same value for the spacetime interval between two events, regardless of which reference frame you use to compute it. The coordinate distances and coordinate times are frame dependent. Different observers assign different spatial distances and different temporal separations to the same pair of events. But the Minkowski interval is the same for all observers. The Minkowski interval is what the physics uses: proper time, proper length, the causal structure of spacetime. All of these are defined in terms of the Minkowski metric, not the coordinate metric. The coordinate distance that the photon traverses 10 billion light years is a frame-dependent number. The Minkowski distance that the photon traverses 0 is frame-independent. The Minkowski distance is what is real in the physically meaningful sense. So the photon, in the physically meaningful metric, traverses 0 distance between emission and absorption. In the sense that matters physically, in the invariant sense, the photon does not travel. It exists along a null geodesic of 0 invariant extent. This leads to the second sense in which light travels without moving. The photon's worldline has 0 invariant length in the Minkowski metric, the invariant metric of spacetime. The photon does not traverse a physical distance. It exists along a geometric object, the null geodesic, that is, in the invariant sense, a single point. Let me now develop the third direction, the question of what motion actually means in physics, and why the photon fails to satisfy the conditions for the concept of motion to apply. In classical mechanics, motion is defined as change of position over time. An object is moving if it is at a different position at a later time than at an earlier time. This requires a concept of position at a time, a concept of later time versus earlier time, and a comparison between positions at different times. For a massive particle, all three of these are well defined. The particle has a position at each moment of its proper time. The proper time provides the temporal ordering. The change in position over proper time is the velocity. For the photon, none of these are well defined in the same way. Position at a time, the photon does not have a well-defined position in its reference frame, because it has no reference frame. The concept of the photon's position at a given moment of the photon's proper time is undefined, because the photon has no proper time at which to measure the position. Temporal ordering. The proper time provides the temporal ordering along a massive particle's worldline. Two events, A and B on the worldline, are ordered by the proper time. If the proper time at A is less than the proper time at B, then A is earlier than B on the worldline. For the photon, the proper time along the entire worldline is 0. There is no temporal ordering of events on the null geodesic in terms of proper time. All events on the null geodesic have the same proper time, namely 0. Change in position. The change in position over proper time is the velocity. For a massive particle, the velocity is well defined because the proper time is well defined and increases along the worldline. For the photon, the velocity would be the change in position over proper time. But the proper time does not change along the null geodesic. It is always 0. The velocity, in this sense, is undefined. It involves dividing by 0. In the specific sense of classical mechanics, the photon does not meet the conditions for motion to be defined. It has no proper time that measures the temporal evolution of its state. It has no reference frame in which its position can be measured at a given moment. It has no velocity in the sense of change of position over proper time. The velocity of the photon that we measure, c, the speed of light, is a coordinate velocity. The change in coordinate position over coordinate time measured in an external reference frame. It is not the photon's own velocity in its own proper time. The photon does not have its own proper time. The speed c is a property of how the photon's null geodesic is oriented relative to the time-like coordinate direction of the observer's reference frame. This distinction is important. The coordinate velocity of the photon c is real and physically meaningful in the sense that it is the same for all observers. But it is a property of the relationship between the photon's null geodesic and the observer's worldline not a property of the photon's own motion. The photon's coordinate velocity tells us how the photon's null geodesic is tilted relative to the observer's time-like direction. For every unit of coordinate time the observer advances, the photon's null geodesic advances c units of coordinate distance. This is a geometric relationship between two curves in the block, the observer's world line and the photon's null geodesic, not a description of the photon's motion in the sense of a physical entity traversing a distance. This is the third sense in which light travels without moving. The concept of motion, defined as change of position over proper time, does not apply to the photon because the photon has no proper time. The photon's coordinate velocity c is a geometric property of the null geodesic's orientation in spacetime, not a rate of traversal. Let me now address the most immediate objection. If light does not move, how does information get from one place to another? How do we see distant stars? How do radio signals reach spacecraft? How does the laser at the grocery store scanner work? The answer is that information, propagation, and motion are related concepts, but are not the same concept. Information propagates from the emission event to the absorption event because those two events are connected by the null geodesic. The information is encoded in the physical properties of the photon, its frequency, polarization, and phase. And those properties are preserved along the null geodesic from emission to absorption. But the propagation of information along the null geodesic is not the same as the photon moving along the null geodesic. The null geodesic simply is, it exists as a complete geometric object in the block, connecting the emission event to the absorption event. The photon exists along the null geodesic at every point on it, simultaneously in the block. The information encoded in the photon's properties is at every point on the null geodesic, simultaneously in the block. From the perspective of an observer moving along a time-like world line, intersecting the null geodesic at the absorption event, the photon arrives with the information encoded in its properties. The observer experiences the arrival as an event, the moment of absorption. But the absorption event and the emission event and every point in the null geodesic between them are all in the block simultaneously. The information does not travel from the emission event to the absorption event. Both events are in the block. The information is in the block at both events simultaneously. What we call the propagation of information is the observer's experience of intersecting a null geodesic that connects two events in the block. This reframing is what changes everything. In the block universe, there is no propagation in time. Because there is no temporal flow, all times are equally real. The photon does not propagate from past to future. It exists along a null geodesic that connects events at different space-time coordinates, and observers moving along time-like world lines encounter the null geodesic at different points on their own journey through the block. Let me now describe specific experiments that make this point vivid, because the abstract argument is strengthened by concrete physical demonstrations. The Hong-Mandel effect, which I described in the previous video, demonstrates that two identical photons arrive at a beam splitter simultaneously and always exit together. The effect depends critically on the photons being indistinguishable, having the same frequency, polarization, and arrival time. Any which path information, any way of distinguishing which photon came from, which source destroys the effect. The Hong-Mandel, or Lee described as the photons interfering at the beam splitter. But this description involves motion. The photons travel to the beam splitter and then travel away from it in the same direction. In the path integral picture, the quantum amplitude for both photons to exit from the same port is the sum of contributions from all possible paths for both photons through the beam splitter, and the interference of those amplitudes produces the always together outcome. In the block universe picture, the Hong-Mandel experiment consists of two null geodesics, the world lines of the two photons that intersect at the beam splitter event. The interference that produces the always together outcome is a property of the quantum state of the two-photon system at the intersection event. There is no motion of photons to the beam splitter and away from it in the block universe sense. There are two null geodesics that intersect at a point in the block, and the quantum state of the two-photon system at that intersection determines the subsequent configuration. Quantum erasure, the restoration of interference after which path information is erased, demonstrates a related point. When which path information about a photon is encoded in an entangled partner, the interference pattern of the first photon disappears. When the which path information in the partner is subsequently erased, the interference pattern of the first photon is restored, but only in the subset of events correlated with the erasure. The delayed choice quantum eraser takes this further. The erasure of the which path information can be performed after the first photon has been detected, and the interference pattern still appears in the correlated subset of first photon detections. The decision to erase, made after the first photon's detection, affects the pattern of those detections. In the block universe, this is not mysterious. The two null geodesics, the first photon's worldline and the second photon's worldline, are connected by their quantum entanglement, which is a property of the two-photon quantum state throughout the block. The measurement on the second photon selects a subset of the first photon's worldline, the correlated subset, and the interference pattern in that subset is determined by the quantum state of the entangled pair, not by any causal influence from the second photon's measurement to the first photon's detection. The entanglement is a feature of the block, a non-local property of the quantum state that connects the two null geodesics throughout their existence in the block. The photons do not communicate with each other across the space between them. The correlation between their properties is a feature of the block's quantum state, present from the moment of the pair's creation. This is the block universe picture of entanglement, not two particles communicating instantaneously, but two null geodesics in the block that share a quantum state, a state that has specific correlations between its values at the two geodesics. The correlations are properties of the block, not signals traveling between the geodesics. What these experiments collectively demonstrate is that light's behavior is determined by the global structure of the quantum state in the block, not by the local trajectory of a photon moving through space and time. The photon does not move from source to detector along a path. The quantum amplitude connecting source and detector is a property of the block. The observed behavior of light emerges from the quantum state of the block. This is how light travels without moving. Not a paradox, but a precise description of the relationship between the photon's null geodesic, the quantum amplitude, and the block universe. The photon is not a traveler. It is a quantum connection in the block, a null geodesic, along which the quantum state of the electromagnetic field has a specific configuration connecting emission events to absorption events through geometric structures of zero invariant extent. The 12 principles in my book include exactly this kind of careful separation between what the physics describes and what our everyday language assumes. Ready to change how you see the world? Get 12 Principles for Understanding the Fabric of Reality at realityprinciples.com. Let me now describe how this picture connects to the Wheeler-Feynman absorber theory of radiation, which is the most radical interpretation of electromagnetism and which makes the absence of photon motion most explicit. John Archibald Wheeler and Richard Feynman had a working relationship that was among the most productive in 20th century physics. Wheeler was the theorist of the grand vision, the man who coined the term black hole, developed the concept of quantum foam at the Planck scale, and pioneered the application of variational principles to gravity. Feynman was the calculational genius, the man who could turn any physical intuition into a precise mathematical formalism. In 1945, they published Interaction with the Absorber as the Mechanism of Radiation, a paper that proposed a fundamentally different picture of electromagnetic radiation. In the standard Maxwell theory, an accelerating charge emits electromagnetic radiation-retarded waves that propagate from the charge into the future at speed c. The radiation is called retarded because it arrives at distant points later than it was emitted. It is delayed by the travel time at c. The radiation propagates whether or not there are any absorbers in the future. A charge accelerating in an otherwise empty universe emits radiation according to the standard theory. Wheeler and Feynman found this picture unsatisfying. They noted that the standard theory involves an infinite self-energy of the electron. The electron interacts with its own electromagnetic field, and that the self-energy is divergent, leading to infinities that were only partially controlled by renormalization. They proposed that the self-energy could be eliminated if the electromagnetic field were not an independent entity, but rather a derived quantity that describes the interaction between particles. Their proposal was this: the electromagnetic field of an accelerating charge is half retarded and half advanced. The retarded part propagates into the future at speed c. The advanced part propagates into the past at speed c. It arrives at distant points before it was emitted in the time-reversed sense. In isolation, this mixture of retarded and advanced fields would produce radiation that propagates both forward and backward in time. But then the absorbers in the future are taken into account. The absorbers respond to the incoming retarded field by themselves, accelerating and emitting fields both retarded and advanced. The advanced fields from all the absorbers propagate backward in time to the source and arrive exactly at the moment of the source's original acceleration. The sum of all the advanced fields from all the absorbers cancels the advanced half of the source's field and reinforces the retarded half. The net result is purely retarded radiation, consistent with observation. This is a remarkable result. The emission of radiation by the source depends on the response of all the absorbers in the entire future of the universe. The source emits because the absorbers absorb, and the absorbers absorb because the source emits. The causality is not one-directional. Emission and absorption are mutually dependent. They are two aspects of a single four-dimensional electromagnetic process that spans the null geodesic connecting them. Wheeler and Feynman showed that this formulation, called the absorber theory, is equivalent to standard electrodynamics for all observable quantities. The predictions are the same, but the physical picture is radically different. In the standard picture, the photon is emitted at the source and then travels to the absorber. The emission is causally prior to the absorption. In the Wheeler-Feynman picture, the emission and absorption are simultaneous partners in a single process. The photon does not travel from source to absorber. The source-absorber connection is a single four-dimensional object, a null geodesic connecting two events that exist as a complete entity in the block. Both the source and the absorber are equal participants in the same null geodesic connection. Wheeler used this picture to make the connection to the block universe explicit. In the block universe, the null geodesic connecting the emission event and the absorption event is a static geometric object. It exists all at once in the block, not as something that unfolds over time. The Wheeler-Feynman theory is the dynamical statement of this geometrical fact. The null geodesic connection between two events is a single physical process, not a sequential emission followed by absorption. Feynman later used the Wheeler-Feynman ideas as the foundation for his path integral formulation of quantum electrodynamics. In the path integral, a photon is not a particle that travels from source to detector along a specific path. It is a quantum amplitude that is the sum over all possible paths from source to detector. Each possible path contributes a complex phase to the amplitude, determined by the action along that path. The amplitude for the photon to reach a given detector location is the coherent sum of contributions from all paths connecting the source to that location. In the path integral, there is no fact about which path the photon took. The photon takes all paths simultaneously, in the sense that all paths contribute to the quantum amplitude. The interference of the contributions from different paths determines the probability of detection at each location. The probability is the absolute value squared of the amplitude. This path integral picture is the deepest statement of how light travels without moving. The photon does not travel along a specific path. It does not have a trajectory. It has a quantum amplitude that is the sum over all geometric connections from source to detector. The interference of all those connections, all those path amplitudes, produces the observed probability distribution for detection. The classical picture of light traveling along rays emerges from the path integral in the short wavelength limit. In this limit, the dominant contribution to the path integral comes from paths near the stationary phase path, the path along which the phase is stationary under small perturbations. The stationary phase path is the classical null geodesic. Geometric optics is the approximation in which only the stationary phase path contributes, and the photon appears to travel along a definite ray. But this is an approximation. In the full quantum description, the photon does not travel along the ray. It contributes amplitude from all possible paths, and the ray is just the path of stationary phase in the short wavelength limit. The motion is an approximation. The quantum amplitude is the reality. The Wheeler-Feynman theory and the Feynman path integral are the classical and quantum realizations of the same insight. The photon is not a traveler going from source to destination along a definite path. It is a connection between two events, a null geodesic in the block, and the quantum amplitude of that connection is computed by summing over all possible geometric paths between the source and destination events. This is how light travels without moving in its most complete and most historically grounded statement. Wheeler and Feynman arrived at this picture by trying to resolve the divergences of classical electrodynamics. Feynman developed it into the path integral as the foundation of quantum field theory. And the block universe picture makes it geometrically precise. The photon is a null geodesic in the four-dimensional spacetime block connecting two events at zero invariant spacetime distance with a quantum amplitude that is the sum over all possible geometric paths between those events. Let me now develop what this means for some of the most familiar phenomena of light: reflection, refraction, diffraction, and interference. Reflection from a mirror is usually described as follows. Light travels from the source to the mirror, reflects off the mirror surface, and travels to the observer. The angle of incidence equals the angle of reflection. This is the ray optics picture. In the Feynman path integral picture, reflection is more subtle. The photon does not travel to the mirror and bounce off. The quantum amplitude for the photon to go from the source event to the detector event is the sum over all possible paths from source to detector, including paths that pass through the mirror at all possible points, not just the point that satisfies the angle condition. Each point on the mirror contributes to the amplitude, with a phase determined by the total path length. For points far from the geometric reflection point, the phases of adjacent paths differ significantly, and the contributions cancel by destructive interference. For points near the geometric reflection point, adjacent paths have nearly the same phase, and their contributions add constructively. The sum over all mirror points is dominated by the contributions from the vicinity of the geometric reflection point, producing the observed angle of incidence equals angle of reflection behavior. This is Huygens' principle in quantum guise. Every point of the mirror is a source of secondary wavelets, and the interference of those wavelets produces the observed reflection. But the quantum version is more precise. It is an interference of probability amplitudes, not of classical waves, and it gives the correct description even for single photons. The key point is that in this description, the photon does not travel to a specific point on the mirror and bounce. There is no fact about which point on the mirror the photon hit. The quantum amplitude for reaching the detector is the sum of contributions from all mirror points, and it is the interference of these contributions that produces the reflection pattern. Refraction is similar. The photon does not travel to the glass surface and then bend at the interface. The quantum amplitude for going from the source to the detector on the other side of the glass is the sum over all possible paths from source to detector, including paths that enter the glass at different angles and points. The interference of these paths produces the Snell's law refraction behavior in the short wavelength limit. Diffraction, the bending of light around obstacles or through apertures, is the case where the path integral picture is most clearly superior to the ray optics picture. In ray optics, light does not bend around obstacles. Shadows have sharp edges. In reality, the shadow edge is fuzzy. Light diffracts into the geometric shadow. In the path integral picture, the photon's amplitude at a point in the geometric shadow is the sum over all paths from source to that point, including paths that pass around the obstacle. The contributions from these paths do not completely cancel, and the photon has a non-zero probability of reaching the geometric shadow. In all these cases, the photon's behavior is determined by the interference of quantum amplitudes for all possible paths, not by a definite trajectory along a specific path. The motion, in the classical sense, is replaced by a superposition of all possible connections between source and detector, with the specific observable behavior emerging from interference. This is the most complete answer to the question of how light travels without moving. In the quantum field theory picture, the photon does not travel along a specific path. It is a quantum amplitude connecting the source event to the detector event summed over all possible geometric paths. The classical picture of light traveling along a ray is an approximation valid in the short wavelength limit of this more fundamental quantum description. The photon does not move from source to detector. The source event and the detector event are connected by a quantum amplitude that is the sum over all paths. The observed behavior of light, straight line propagation, reflection, refraction, diffraction, interference, all emerge from the interference of probability amplitudes for all possible paths. The motion is replaced by interference. Let me now describe what happens to this picture in the curved spacetime of general relativity, because the photon's relationship to motion becomes even more interesting when gravity enters the picture, and because gravitational lensing is one of the most dramatic demonstrations of the photon's null geodesic worldline. In general relativity, the geometry of spacetime is curved by the presence of matter and energy. The Einstein field equations g mu plus will mu equals 8 pi g divided by c to the power of 4. T mu relate the spacetime curvature described by the Einstein tensor g mu to the distribution of matter and energy described by the stress energy tensor T mu. The metric tensor k mu, which encodes the geometry of spacetime, is the dynamical variable of general relativity. The null geodesics, the paths along which photons propagate, are determined by the metric. In flat spacetime, null geodesics are straight lines in coordinate space. In curved spacetime near a massive object, null geodesics curve. This curvature is what we observe as the gravitational bending of light. Gravitational lensing was first predicted by Einstein in 1915 as a consequence of his general theory of relativity, and was confirmed by Eddington's observation during the solar eclipse of May 29, 1919. By comparing the positions of stars near the sun during the eclipse, when the stars could be seen because the sun's disk was covered by the moon to their catalog positions, Eddington measured a deflection of starlight consistent with the general relativistic prediction. Einstein's prediction was twice the Newtonian prediction, and the observation confirmed the general relativistic value. The general relativistic prediction for the deflection of light by the sun is 1.75 arcseconds, a tiny but measurable angle. Modern measurements, using very long baseline radio interferometry to observe distant radio sources whose apparent positions shift as the sun passes in front of them, have confirmed the Einstein deflection to better than 0.01%. The bending of light in a gravitational field is sometimes described as light being attracted by the gravitational pull of the massive object. This description is misleading in two ways. First, the photon has zero rest mass, and gravity in the Newtonian sense acts on mass. The photon has no mass to be pulled. Second, and more fundamentally, the bending of light is not caused by a force acting on the photon. It is caused by the curvature of space-time. The null geodesics in curved space-time are not straight lines, and the photon follows the null geodesic of the metric. In the block universe picture, the gravitational bending of light is a feature of the null geodesics in the space-time block. The null geodesics exist in the block as static geometric objects. Near a massive object, the space-time metric is curved and the null geodesics are curved accordingly. The photon exists along these curved null geodesics in the block. There is no photon moving along the null geodesic in response to a gravitational force. There is a curved null geodesic in the block, and the photon exists along it. Gravitational lensing, the phenomenon in which a massive object or cluster of objects focuses light from background sources, creating multiple images, arcs, and Einstein rings, is a consequence of the geometry of null geodesics in curved spacetime. The light from a background galaxy, for example, follows multiple null geodesics through the curved spacetime of an intervening galaxy cluster, arriving at the telescope from different apparent directions and forming multiple images or a ring. In the block universe, these multiple images are the intersections of the observer's worldline with multiple null geodesics, each connecting the emission event at the background galaxy to the absorption events at the telescope's detector. The multiple null geodesics exist simultaneously in the block. They are static geometric objects in the four-dimensional space-time manifold. The observer's worldline intersects all of them at the detection events, and the observer perceives multiple images of the same background galaxy. The photons in the multiple images have traveled along different null geodesics through the curved space-time. Each null geodesic has a different coordinate path, a different route through the galaxy cluster. The photons arrive at the telescope at slightly different times because the coordinate path lengths differ. This time, delay between images, the Shapiro delay, named for Erwin Shapiro, who first calculated it in 1964, is a measurable prediction of general relativity. The Shapiro delay for light passing near the sun is approximately 200 microseconds. But each individual photon in each image has accumulated zero proper time along its null geodesic, regardless of the coordinate path length and the coordinate travel time. The photon that arrives slightly later along a longer null geodesic has still accumulated zero proper time. The Shapiro delay is a feature of coordinate time, not proper time. In the block, all the null geodesics have zero Minkowski length, regardless of their coordinate extent. This is the general relativistic extension of how light travels without moving. In curved spacetime, the null geodesics are curved by the spacetime metric. The photon follows these curved null geodesics, the straightest possible null paths through the curved geometry. The photon does not move along the null geodesics in the proper time sense, because the proper time is zero. It exists along the null geodesics in the block. The null geodesics curve near massive objects because the spacetime metric curves there, and the photon follows the curved null geodesic as a consequence of the geometry. The entire rich phenomenology of gravitational lensing, the multiple images, the arcs, the Einstein rings, the time delays, the magnification is a consequence of the geometry of null geodesics in curved spacetime. The photon does not respond to gravity as a massive particle would. It follows the null geodesics of the curved metric, and the null geodesics are curved by the mass distribution. The photon travels without moving through curved spacetime, following paths of zero proper time and zero Minkowski length that are curved by the curvature of the geometry. Let me now develop the philosophical resolution of the apparent paradox completely, because the paradox is not just a physics puzzle, but a conceptual puzzle about what we mean by travel, movement, and existence. The paradox is this: light clearly travels, it leaves a source and arrives at a destination with a finite transit time measured by clocks. But light does not move. It has no proper time no rest frame, no proper time velocity. Both seem true, and they seem contradictory. The resolution is that travel and motion, while related in everyday experience, are distinct concepts that come apart in the case of the photon. Travel, in the everyday sense, means an entity starting at one place and arriving at another, with the journey taking some time. Light does this. It starts at the sun and arrives at Earth, and the journey takes 8 minutes by our clocks. This is the coordinate description of the photon's null geodesic, the description from an external time-like observer's perspective. Motion, in the proper physics sense, means an entity traversing a proper distance over a proper time. A massive particle that moves from point A at proper time tau 1 to point B at proper time tau 2 has traversed a proper distance of c times tau 2, tau 1 at an average velocity of position B, position A, tau 2, tau 1. Light does not do this. The proper time is 0, the proper distance is 0, and the proper time velocity is undefined. The photon travels in the coordinate sense but does not move in the proper time sense. These two descriptions are not contradictory because they refer to different coordinate systems. The coordinate description is the description from the external observer's time-like frame. The proper time description is the description from the photon's own frame, which does not exist, but whose limit gives 0 proper time and 0 proper distance. The two descriptions are related by the Lorentz transformation. As an observer's velocity approaches c, their proper time for any fixed coordinate journey approaches 0, and their proper distance approaches 0. In the limit, both proper time and proper distance are 0. The photon is the limiting case, the limit that is not achieved by any massive observer, but that the photon realizes exactly. The coordinate description is perfectly real and valid from the perspective of massive observers. The 8-minute journey of a photon from the sun to Earth is real in the sense that it affects the coordinate positions and times of events in the observer's reference frame. But the proper time description, 0 time, 0 distance, is equally real in the sense that it is the invariant, frame-independent description of the photon's space-time history. The paradox dissolves when you recognize that the coordinate description and the proper time description are not two descriptions of the same thing from two perspectives. They are descriptions of two different aspects of the same physical situation. The coordinate description describes a relationship between the null geodesic and the observer's time-like worldline, while the proper time description describes the intrinsic geometry of the null geodesic itself. The null geodesic has 0 intrinsic proper time extent. This is a fact about the null geodesic itself, independent of any observer. The null geodesic also has a definite coordinate extent in any observer's frame, 8 light minutes in the Sun-Earth case. This is a fact about the relationship between the null geodesic and the observer's coordinate system. Both facts are true. Neither contradicts the other. The photon travels in the coordinate sense. The photon does not move in the proper time sense. This is how light travels without moving. Let me now develop what this picture means for how we understand light in everyday experience, because the physics is most convincing when it connects to things we can see and touch and observe. Look at a beam of sunlight coming through a window. The standard description is that the light left the sun's surface 8 minutes ago, traveled 150 million kilometers through the vacuum of space, and arrived at your window. The photons are arriving one by one at 300,000 kilometers per second. The light is moving. The block universe description is different. The null geodesics connecting the sun's surface 8 minutes ago to the photoreceptors in your retina right now are static geometric objects in the four-dimensional space-time block. They exist in the block all at once, from the emission events at the sun to the absorption events in your eyes. The photons exist along these null geodesics simultaneously in the block. You, moving along your time-like world line, have arrived at the space-time coordinates where you intersect the null geodesics, where your world line meets the photon world lines. You did not receive the photons. your world line reached the points where the photons exist in the block. The photons were there all along at their null geodesic coordinates in the block. You were traveling through the block, and at this moment, your world line intersects the null geodesics from the Sunday. This reframing is not just philosophical. It reflects the actual physical structure that special and general relativity describe. The coordinates that we use, the 8 minutes, the 150 million kilometers, are real in the sense that they affect the causal structure and the observable relationships between events. But the invariant geometry, the null geodesic, its zero Minkowski length, the zero proper time, is more fundamental. It is the frame-independent description of what is actually happening in the space-time block. The sun is not sending you messages. The sun is embedded in the space-time block at its space-time coordinates, emitting photons, creating null geodesics that connect its past moment's surface to your present retina. You intersect those null geodesics as your world line advances through the block. The connection is geometric, not dynamical. The light does not travel to you. You travel to the point where the light exists in the block. Now consider the light from a star 1,000 light years away. The standard description: the light left the star 1,000 years ago and has been traveling through space ever since, arriving at your telescope tonight. The block universe description: the null geodesics connecting the star's surface 1,000 years ago to your telescope tonight exist in the block simultaneously, from emission to absorption. The star's light is in the block right now at every point along the null geodesics, just as surely as your telescope is in the block right now. Your telescope's world line is advancing through the block, and tonight it intersects the null geodesics from that star. The star from 1,000 years ago and your telescope tonight are connected in the block through null geodesics of zero Minkowski length. They are, in the invariant geometry, at zero space-time distance from each other. Your observation tonight is a direct geometric connection to an event 1,000 years ago and 1,000 light years away, a connection of zero invariant extent. This is the universe as the block universe reveals it. A four-dimensional structure in which events are connected through null geodesics of zero invariant length, and observers traverse the block along time-like world lines, encountering those null geodesic connections at the moments when their world lines intersect them. Every astronomer looking at the sky is doing exactly this. Their world line is intersecting null geodesics from events across cosmic history and cosmic distance. The light from the Big Bang's afterglow, the cosmic microwave background, exists in the block as null geodesics, connecting the last scattering surface at 380,000 years after the Big Bang to the detectors of the Planck satellite or ground-based telescope tonight. Those null geodesics span 13.4 billion years of coordinate time and approximately 46 billion light years of coordinate distance. They have zero Minkowski length. The moment of emission and the moment of detection are at zero invariant space-time distance. When we look at the universe, we are not receiving ancient light from the past. We are intersecting null geodesics that connect our present to events across cosmic history. The past and present are in the block simultaneously, connected by null geodesics of zero invariant extent. Every photon that reaches us is a zero-length geometric connection to some moment of the universe's past. This is what it means that light travels without moving. The photon is not a messenger. It is a geometric connection. The travel is coordinate real and observer real, but not proper time real and not invariant metric real. The motion is a description of the relationship between the null geodesic and the observer's time-like world line, not of anything traversing a distance in its own proper time. How light travels without moving is the deepest fact about the relationship between information, causality, and the geometry of space-time. And understanding it changes how you experience every moment of vision, every intersection of your world line with the null geodesics that connect you to the universe. The 12 principles in my book are built to convey exactly this: that physics, taken all the way to its conclusion, without compromise, reveals a universe that is stranger and more beautiful than anything intuition provides, and that understanding the strangeness is what changes how you live within it. Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. What does it change for you to understand that light connects events without traversing them? Tell me in the comments. The 12 principles I have assembled for understanding the fabric of reality are built to convey exactly this kind of insight. The recognition that what physics describes, when you take it all the way to its conclusion without compromise, is stranger and more beautiful than anything built from everyday intuitions. Ready to change how you see the world? Get 12 principles for understanding the fabric of reality at realityprinciples.com. What does it change for you to understand that light connects events without traversing them? Tell me in the comments. If this changed how you think about light, motion, and the geometry of space-time, if the picture of the photon as a null geodesic in the block universe rather than a particle traveling from source to destination looks different. Now tell me in the comments. Tell me whether the claim that light does not move in the proper time sense makes light feel more or less real to you. Tell me whether the path integral picture of photons as quantum amplitudes summed over all paths changes how you think about where the photon actually goes. And subscribe if you want to keep going into the places where the physics of the universe reveals facts about the nature of reality that our everyday language was not built to describe. The universe connects its events through light, not by sending messengers across distances and times, but by weaving null geodesics through the space-time block geometric connections of zero invariant extent that link every observable event to every observer who can see it. Every moment of vision is an observer's worldline intersecting a null geodesic. The photon does not arrive. The observer arrives at the point where their worldline meets the null geodesic. That is how light travels without moving. That is what the block universe, the null geodesic, the Lorentz transformation, and the path integral together reveal about the most fundamental connection in the physical universe. The bending of light in a gravitational field is sometimes described as light being pulled by gravity, but this description is misleading. The photon has zero rest mass and does not couple to gravity in the Newtonian sense of a mass being attracted by another mass. The photon's path curves in a gravitational field because the space-time geometry is curved. The null geodesics in curved space-time are not straight lines in the Euclidean sense because the space they traverse is not Euclidean. The photon follows the null geodesic of the curved space-time metric. The null geodesic is curved because the metric is curved. The photon does not deviate from the geodesic. It follows it exactly as a massless particle must. The curvature of the path is not caused by a force acting on the photon. It is a consequence of the geometry of the space-time through which the null geodesic passes. This is analogous to the bending of massive particle paths in a gravitational field. A freely falling massive particle follows a time-like geodesic of the curved space-time. The geodesic curves near a massive object, not because a force pulls the particle toward the mass, but because the space-time geometry is curved and the geodesic, the straightest possible path, curves with the geometry. For the photon, the null geodesic in curved space-time still has zero Minkowski length. In the local sense, the metric interval along the null geodesic is zero at every point. The photon still accumulates zero proper time. The bending of the null geodesic in a gravitational field does not change the zero proper time property. What changes is the coordinate path of the null geodesic. In flat space-time, null geodesics are straight lines in coordinate space. In curved space-time near a massive object, null geodesics curve. The curvature is determined by the metric, by the distribution of matter and energy in the space-time. The photon follows the curved null geodesic of the curved space-time, and an observer far from the massive object sees the photon arrive from a direction that differs from the direction of the original source. In the Bloch universe of general relativity, the photon's worldline is a null geodesic of the curved spacetime metric. This null geodesic is a static geometric object in the four-dimensional block. The photon exists along the null geodesic at every point on it in the block. The null geodesic curves near massive objects because the space-time metric is curved there. The photon does not curve its path in response to a force. It simply is along the null geodesic of the geometry. Gravitational lensing, from this perspective, is not the photon being deflected by gravity. It is the null geodesic of the space-time metric being curved by the presence of mass, and the photon existing along that curved null geodesic. The deflection of light by the sun, the Einstein ring images produced by galaxy-scale lensing, the multiple images of background galaxies produced by galaxy cluster lensing, all of these are consequences of the geometry of the null geodesics in the curved spacetime around massive objects. The Bloch universe picture makes this especially clear. The null geodesic exists in the block as a complete geometric object, curved by the spacetime metric near massive objects. The photon exists along this geodesic in the block. There is no photon moving along the geodesic over time. There is a geodesic in the block and a photon that exists along that geodesic in the block, and observers who encounter the geodesic at the absorption event. This is the Bloch universe picture of light bending in gravitational fields. The null geodesics exist in the curved spacetime block as static geometric objects, and the photon exists along them without moving. Let me now address the philosophical implications of the claim that light travels without moving, because the claim is not just a physics statement, but a statement about the nature of physical concepts. The concept of motion requires three things: an object, a position of that object at a time, and a change of position over time. For the photon, the first requirement is satisfied. The photon is an object, or at least a physical entity. But the second and third requirements are problematic. The position of the photon at a time requires a reference frame, and the photon has no reference frame. In any reference frame, any observer's coordinate system, the photon has a definite coordinate position at a given coordinate time. But the coordinate position and coordinate time are frame dependent. Different observers assign different coordinates to the same photon event. The physically meaningful, frame-independent description of the photon event is its space-time coordinates in the block, its location in the four-dimensional space-time manifold. And in the block, the photon event is simply a point on the null geodesic. It does not have a position at a time in the frame-independent sense. It has a space-time location. The change of position over time requires a proper time, and the photon has no proper time. The proper time along the photon's worldline is zero everywhere. There is no temporal parameter that increases along the null geodesic and provides the reference for change. In the absence of a reference frame and a proper time, the concept of motion in the classical sense does not apply to the photon. The photon is not at rest. It has a definite coordinate velocity c in every reference frame. But it is not in motion in the sense of having a position at a time and changing that position over proper time. It is in an intermediate state that has no classical analog, a physical entity that exists along a null geodesic of zero invariant length with a coordinate velocity that is defined relative to external observers, but no proper frame velocity defined relative to itself. The word travel in the phrase light travels without moving is the concession to our language. We say light travels because we observe photons arriving from distant sources, because we measure their propagation speed, because we describe them as rays going from here to there. But the physics, taken seriously, says something different. The photon does not travel in the physically meaningful sense of traversing a proper distance over a proper time. It exists along a null geodesic that has zero invariant extent connecting events that are in the Minkowski metric at zero space-time distance. The title of this video is A Paradox: How Light Travels Without Moving. The paradox is resolved by recognizing that travel in the everyday sense means something different from what the physics describes. The everyday sense of travel requires a traveler who experiences the journey, who moves through space, experiences time passing, feels the distance traversed. The photon is a traveler in this sense only from the external observer's perspective. From the photon's own excluded but limiting perspective, there is no journey, no distance, no time. There is only a null geodesic of zero extent connecting two events in the block. The universe does not look the same from every perspective. From our time-like perspective, light travels at c across enormous distances and times. From the photon's excluded perspective, the universe has zero extent, no distance, no time, no journey. Both descriptions are consistent with the physics. Neither is more real than the other. They are two perspectives on the same geometric object, the null geodesic measured by the same metric, the Minkowski metric, from different orientations in the space-time block. What changes everything about understanding this is not the specific physical fact, the zero proper time, the null geodesic, the zero Minkowski length, but the realization of what it implies about the nature of travel, motion, and existence. Light does not experience the universe. Light is the universe's way of connecting events without any entity having to travel from one to the other. The connection is geometric, not kinematic. The photon is not a messenger carrying information from source to destination. It is the geometric connection between the source event and the destination event, a null geodesic in the block. Every beam of light you have ever seen, every photon that has ever entered your eyes, was not a traveler arriving from a distant source. It was a geometric connection, a null geodesic, between a distant event and your retina, existing simultaneously in the block at both ends and at every point between them. The connection was there in the block, waiting for your retina to intersect it. The photon did not arrive. Your worldline arrived at the point where it intersected the null geodesic. This is how light travels without moving. This is the strangest and most profound fact about the particle that connects us to the universe. And this is the picture that the block universe and the null geodesic together reveal when you take the physics all the way to its conclusion. The universe connects its events through light not by sending messengers, but by weaving null geodesics through the space-time block. If this changed how you think about light, motion, and the geometry of space-time, if the picture of the photon as a null geodesic in the block universe, rather than a particle traveling from source to destination, looks different, now tell me in the comments. Tell me whether the claim that light does not move, in the precise physical sense, makes light feel more or less real to you. Tell me whether the path integral picture of photons as quantum amplitudes summed over all paths changes how you think about where the photon actually goes. And subscribe if you want to keep going into the places where the physics of the universe reveals facts about the nature of reality that our everyday language was not built to describe.